A high dose can kill you in a few seconds, or a few minutes, or a few days. Lower doses can disrupt your DNA and make you sick. That's how it causes cancer. So we need to keep people and things from getting irradiated in the first place, and pieces of paper aren't going to do it. Scientists in the nuclear industry often use concrete and stainless steel, built up in layers as much as 3 meters or 10 feet thick. See, with enough shielding, you can contain even nuclear radiation. You see, in this game, rock beats paper.
The first United States nuclear power plant began commercial operation in 1957.
Wow, that is neat, Mr. Sanders.
And we'll build more reactors because they're clean and completely safe.
My father says spent fuel from reactors is radioactive for thousands of years and is dangerous.
Don't worry, Mary. The scientists in the future will fix everything.
Mr. Sanders, can't nuclear power plants have meltdowns and kill people?
That sounds like a lie that the communists made up, Tommy.
But my father told me that too, Mr. Sanders.
What's his name? I'd like to write it down in my little book.
I'm going to tell my father what you're doing, Mr. Sanders.
Is nuclear power really that dangerous, Mr. Sanders?
Oh, yes, Tommy. I just didn't want to admit it to that know-it-all Mary.
Well, if you had your way, what would you do with the waste?
I'd put the waste in Yucca Mountain.
Now, why do you like Yucca Mountain?
Well, it's the best method preferred to date for dealing with spent fuel storage.
Do you think there'll ever be a better method?
You never know what some engineer's gonna think up down the road, so I can't say it's the best.
Look out there. Looks like we're in the middle of nowhere. And in a sense, we are. We're out here near Yucca Mountain, where we're going to store nuclear waste. But it's only 100 miles from there to Las Vegas. That's not very far at all, especially if you have to keep that waste away from people for 10,000 years.
Well, we're on Yucca Mountain crest, about 5,000 feet above sea level. The repository would be almost directly beneath us.
How far?
About 1,000 feet down to the repository, about another 1,000 feet beneath that to the water table.
Why Yucca Mountain? Why here?
I think the top reasons are it's a very dry site. We don't get much rain out here at all. It's a very remote location. It's many miles away from any population centers. And a third reason I would say because of the rock. Because the rocks themselves are very stable, and there's a large enough block of rock to be able to accommodate the nuclear waste.
In 1987, Yucca Mountain was chosen as the best site to evaluate for a long-term national nuclear fuel repository. Using this specially developed boring rig, a system of tunnels known as the Exploratory Studies Facility, or ESF, was created inside the mountain to allow scientists to examine and test the rocks.
This is volcanic tuff, and it's the material that was ejected from a volcano. You want the rock to be strong and stable and to be able to support the tunnels and drifts into which people and the waste would have to go.
But what if it gets wet? That's the thing, right?
Well, that is the big question, Bill, and that's a lot of the studies that we're doing out here are looking at how does water move through the mountain? How much water is there? How could it come in contact with the waste? But remember, Yucca Mountain is in the Mojave Desert. We only get between 4 and 6 inches of rain a year here. It's an extremely dry environment. We've got one of the deepest water tables in North America here. If you don't have water, there's really no other mechanism for the radionuclides to come in contact with the public.
How many miles of tunnel would there be ultimately?
The amount of tunnel we would need to emplace 70,000 metric tons is approximately 65 miles of tunnel.
And how many do you have so far?
Right now we just have these two, and these are not part of the repository. These are part of the exploratory studies. They would not be used for emplacement.
Do you think this facility will do the job storing 70,000 metric tons?
I believe it will. Being a researcher, I have confidence in science and engineering.
And 10,000 years?
10,000 years.
Rain, shine, earthquakes, we're good.
As a scientist, I believe it's good, but but I make no guarantees.
It's going to be very hard indeed to build a structure that's earthquake-proof, leak-proof, and erosion-proof that lasts at least 10,000 years. It's never been done. Consider the pyramids. They're some of the longest-lasting civil engineered structures on Earth. But every single one of them has been broken into. And the vandals and archaeologists who got in were not deterred in any way by big, heavy stone walls or spooky curses. Maybe they just couldn't read the hieroglyphic warning. Now, the pyramids were built by thousands of Egyptians working together, and the structures have lasted a long, long time. But they did not protect the valuables inside. What makes us think that we can? So is Yucca Mountain a good idea?
Yucca, I'm worried, is going to be one of the worst environmental mistakes that our species has ever made. The primary scientific arguments for Yucca Mountain was that it was very dry and that the geologic formation was such that moisture would not penetrate into the mountain, get into the radioactive waste, and migrate for hundreds of thousands of years. But that argument went completely out the window when the Nuclear Regulatory Commission dug out a little cavern within Yucca Mountain and put in sensitive equipment to find out if there was moisture. After 6 months, it turns out they lost all their data because there was so much moisture in the cavern that shorted out all the electrical equipment. So they changed the rules. They changed the rules so that you could now in your model rely upon the canister in which the waste was put. And even that doesn't get them very far because no one has built any canister that's lasted 10,000 years. And 10,000 years, which is the period they say is going to degrade in, almost all of the plutonium is still left.
So where did 10,000 years come from?
It's completely arbitrary. The Department of Energy's models were showing that the peak exposure was at 300,000 years and that they couldn't meet the standard. So at that point, the Department of Energy had estimated that the canisters didn't start to degrade until 11,000 years. So they said, why don't we have to comply with the rules only for the first 10,000? Plutonium is the most dangerous thing that human beings have ever made. It will probably be our demise. A millionth of an ounce, the size of a speck of dust, if inhaled, will cause lung cancer. A few pounds, the size of a grapefruit that you can hold in your hand, will bring down a city if used in a nuclear weapon. And it has a 24,000-year half-life.
We measure radioactivity in what's called half-lives. You see, the atoms in radioactive material spontaneously just break apart or decay. Now, we can't tell when an individual atom will decay, but we can tell when a fraction of them will. So a half-life is the amount of time it takes for half the atoms in a piece of radioactive material to break apart. Now, plutonium has a half-life of 24,000 years. So let's say this red water is the plutonium in a spent nuclear fuel rod fresh from the reactor. Well, after one half-life, 24,000 years, diluting this water by half, it looks like this. After two half-lives, 48,000 years, it would look like this. After 10 half-lives, 240,000 years, the water starts to look pretty clear. Now, plutonium is notorious. It's especially radioactive. It's 20 million times more radioactive than uranium dug from a mine. You see, we're not talking about potato salad left out in the sun. We're talking about plutonium. Now, the legal requirement for storing this material is only 10,000 years. That would be over here someplace. That's not even half of a half-life.